Clear? Note it down. Now the next question. Simplify tan inverse a plus bx, b minus ax, x is less than b upon a. Take b common from here, but we get a upon b plus x, 1 minus a upon b into x. So tan inverse a upon b plus x, 1 minus ab into x. Now we know the formula. Tan inverse this is equals to tan inverse a plus tan inverse b. Tan inverse a plus tan inverse b is equals to tan inverse a plus b upon 1 minus a into b. Now next second part. Tan inverse a cos of x minus b sin of x, b cos of x plus a sin of x. Now a we are given minus pi by 2, limit is minus pi by 2 less than x less than pi by 2, a upon b tan x is greater than minus 1. So, but we have taken b cos x. So, a upon b, b is common, sin upon cos is tan. Similarly, we have taken b cos x from the denominator, common, tan inverse b cos of x upon b cos of x. So, 1 plus a upon b tan x. So tan inverse a minus b 1 plus a into b. So this is the formula for tan inverse a minus tan inverse b. Tan inverse a upon b minus x. Tan inverse a minus tan inverse b, that is equals to tan inverse a minus b upon 1 plus a into b. Third part, tan inverse 3a square x minus x cube upon a cube minus 3a x square minus 1 by root 3 less than x by a 1 upon root 3. So from the numerator and denominator, what we have to take? We want x upon a. So a cube common. So 3x upon a minus x cube upon a cube, 1 minus 3 x upon a square, a cube, a में से a cube common लिया, so we have to divide by a square, x square is already here, so x upon a square. So tan inverse 3x upon a minus x upon a cube 1 minus 3x upon a square. Now we have one formula, tan inverse 3x minus x cube 1 minus 3x square, that is equals to 3 tan inverse x. So what we get here? Instead of x we have x upon a here. So we get 3 tan inverse x upon a. Now next is side, use the formula here. Tan inverse x plus tan inverse y is equals to tan inverse x plus y 1 minus xy if x into y is less than 1. X into y is less than 1 here. So use the formula tan inverse x plus y 1 minus x into y. So what we get? Taking the LCM, 13 into 7. So 13 plus 7. So we get tan inverse 13 plus 7, 20. 91 minus 1 is 90. So we get tan inverse 2 by 9, that is equals to right hand side. Second part, tan inverse 1 by 2 plus tan inverse 1 by 5 plus tan inverse 1 by 8 is equals to pi by 4. First take two terms, apply the formula tan inverse x plus y 1 minus x into y plus tan inverse 1 by 8 as it is. So we get tan inverse 5 into 2, 10, 5 plus 2, 10 minus 1 plus tan inverse 1 by 8. So we get tan inverse 7 upon 9 plus tan inverse 1 by 8. Again apply the formula here. Tan inverse a plus b 1 minus a into b. So tan inverse, take the LCM. 72 minus 7. So tan inverse we have tan inverse 1 and 1 is the value for tan pi by 4. So we get the answer as pi by 4. Now third part, tan inverse 3 by 4 plus tan inverse 3 by 5 minus tan inverse 8 by 19 is equals to pi by 4. First solve to tan inverse A plus tan inverse B. Product is less than 1. Tan inverse A plus b, or we can say x plus y 1 minus x into y minus tan inverse 8 by 19. So what we get? Take the LCM. 5 into 4, 5 into 3, 4 into 3, 5 into 4, 20. So 20 minus 3 into 3 is 9 minus tan inverse 8 by 19. So tan inverse minus tan inverse 8 by 19. Now apply the formula tan inverse x minus tan inverse y. That will be equals to tan inverse x minus y upon 1 plus xy. So tan inverse x minus y 1 minus x into y. So tan inverse 19 into 11 19 into 27 11 into 8 minus 27 into 8 So what we get? plus 8, 4. 9 plus 6, 1 plus 1 and 2 plus 2. So we get tan inverse 1. And 1 is the value for tan pi by 4. So we get the result as pi by 4. Now fourth part. Prove that tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is equal to pi by 4. So apply the formula here. Tan inverse A plus B, tan inverse A plus B, 1 minus A into B. Tan inverse A plus B, 1 minus A into B. Take the LCM. 5 into 7, 7 plus 5, 35 minus 1 plus tan inverse 8 into 3, 24, 8 plus 3, 24 minus 1. So tan inverse 7 plus 5, 12 upon 34 plus tan inverse 11 upon 23. Again apply the same formula. Tan inverse A plus tan inverse B. Tan inverse A plus B, 1 minus A into B. So tan inverse 23 into 17, 23 into 6 plus 11 into 17 upon 23 into 17 11 into 6. 23 into 17 will get cancelled. So we get tan inverse 138 plus 187. 11 minus 6, 8 minus 6. So we get tan inverse 1. Again tan inverse 1 is the value for pi by 4. Now next one. Prove that sine inverse 3 by 5 plus sine inverse 8 by 17 is equals to sine inverse 77 upon 85. Sine inverse x plus sine inverse y, that is equals to sine inverse x into square root of 1 minus y square plus y into square root of 1 minus x square. Left hand side, apply the formula. Sine inverse x 1 minus y square, 8 square, 17 square plus y 3 square and 5 square. So what we get? Sine inverse 3 by 5, 289 minus 64. We get 225, square root of that, plus 8 by 17, 25 minus 9, 16, square root of 16. So what we get? Sine inverse 15 into 3, 8 into 4. So sine inverse by taking LCM 77 upon 85. Second part. Sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65 is equal to pi by 2. Sin inverse x plus sin inverse y, x 1 minus y square plus y 1 minus x square plus sin inverse 16 upon 65. So sin inverse 4 by 5, 169 minus 25, 144 square root of that plus 5 by 13, 25 minus 69 square root of 9 plus sin inverse 16, 65. So what we get? 13 into 5 is 65. So we get sin inverse 63 by 65 plus sin inverse 16 by 65. Again apply the formula. Now here we have 16 upon 65, let it equals to theta. Then we get sin theta is 63 by 65. Sin is P upon H. So base is hypotenuse square minus base square perpendicular square. Four double 25 minus 3969, 15 minus 9, 11 minus 6, 11 minus 9. So we get it as 60. So cos is base upon hypotenuse. So instead of this theta, we can write it as cos inverse 16 upon 65 plus sin inverse 16 upon 65. And we know sin inverse x plus cos inverse x, that is equals to pi by 2. You can solve like this also. Since the calculation will be lengthy, so we will solve like this. Now next part. Sin inverse 3 by 5 plus sin inverse 8 by 17. Prove that it is equals to cos inverse 36 by 85. Use the formula here. Sin inverse x 1 minus y square, 8 square, 17 square plus y 1 minus x square. So we get it as sin inverse 3 by 5, 289 minus 64, 225. And square root of this 25 minus 9, 16. So we get sin inverse 7 into 5, 15 into 3, 8 into 4. We get it as sin inverse 77 upon 85. Let this equal to theta. Then sin theta is 77 upon 85. P upon H. Find the base. 85 square minus 77 square. So we get 7225 minus 5929. 15 minus 9, 11 minus 2, 11 minus 9, 6 minus 9, that is 36. So we get cos theta as base upon hypotenuse. So we get theta as cos inverse 36 by 85. Note it down. Next is sin inverse 3 by 5 plus cos inverse 12 by 13. Prove that this is equals to cos inverse 33 by 65 is equals to sine inverse 56 by 65. Let it equals to theta. Then what we get? Cos theta as base upon hypotenuse. 169 minus 144 square root of 25. Here we have sine. So sine is P upon H. So we get it as sine inverse 3 by 5 plus sine inverse 5 by 13. Apply the formula here. Sine inverse x 1 minus y square plus y square root of 1 minus x square. So sine inverse 3 by 5, 144, 5 by 13, 16, so 4 by 5. So sine inverse, so we get it as sine inverse 56 by 65. Now we want to prove it equals to cos inverse. So let's sine of this function is equals to phi. Sine inverse